हाँ, काफी टाइम. ओके. ओके. ऑलराइट. So we're live. Welcome to the podcast. इसको स्पॉटिफाई पे डाल दें.
जरूर सर.
एक दिन स्पॉटिफाई पे
स्पॉटिफाई.
स्पॉटिफाई पे
स्पॉटिफाई.
करते हैं कि जे व्हाट इज अ यू नो why one should not prepare for JEE seriously, and what is your inspiration of doing that? काम से कैसे बचें? How to protect yourself from hard work? How to keep your life simple?
वो पॉडकास्ट मैं बनाऊं.
हाँ, मतलब I will ask you question. आंसर तो तुम्हारे पास ही सारे इसके. कुछ खास ही है कुछ बंदा. हाँ जी. So let's talk about.
अब सोबराज.
हाँ, वो तो सुधर गया अब. काफी काफी फर्क है भाई. ओके.
चार सोबराज में या मेरे में.
चाल छोबरा तो क्या सुधरेगा अब. ऑलराइट. So thermodynamics. थर ये यार
थर्मो.
मैं थोड़ा थर्मो
डायनामिक.
डायनेमिक्स हो गया आपका.
केमिकल
11वीं.
थर्मोडायनामिक्स.
हाँ, ये
केमिकल.
केमिकल वाला है. Because all the forms of energy here which are being referred to are with respect to chemical changes and chemical
फिजिक्स एंड केमिस्ट्री मिक्स.
concepts are pretty, underlying factors are same. Chemicals have different names given to them because different reactions are there. Okay, so chemical changes and chemical substances uh, are involved in this. This is, and it deals with different forms of energy and what are the relationships between those different forms of energy. So it deals with different forms of.
अपने इंजीनियरिंग में भी पढ़ा था क्या थर्मोडायनामिक्स.
बहुत अच्छी तरह से. मैकेनिकल इंजीनियरिंग का हिस्सा ही है.
तो बस
फिर
इलेक्ट्रिकल थी.
हाँ, लेकिन पढ़ना पड़ता है. मे बी वी शुड नो व्हाट आर different forms of energy and what are the quantitative relationships between them and what are the quantitative relationships between them, मतलब relationship in the formula between energies के बीच में. So and what are the quantitative relations between them. So this is the branch of science we're going to study, and so the context of our discussion is only this. We're not getting into physics or any physical quantity.
फिजिक्स में भी है
And
वैसे हमारे पास.
हाँ, बहुत बढ़िया करेंगे. We will do it. So there are three laws that govern. Okay, first law of thermodynamics, then second law of thermodynamics, and third law of thermodynamics. There are three laws we have to study, and
आपको पता है किस साइंटिस्ट ने बनाया इसको थर्मोडायनामिक्स को.
जरूरत तो नहीं था.
नहीं सर. जेम्स प्रेस्कॉट जूल.
अच्छा, नाम सुना हुआ है. ओके. जूल भाई तो अब सबको पता ही है. Okay, so when do we apply these? When these are, so if you have a system, okay, a system and system is in equilibrium, which means it is not exchanging energy with any other system. And then due to some change, it acquires a different equilibrium state. Okay, so equilibrium state second, it is at first a reaction happens and some it reaches. तो ये जो एक इक्विलिब्रियम से दूसरे इक्विलिब्रियम में फिर तीसरे चौथे के अंदर आएगा. We will apply these three laws of thermodynamics only to these states. We'll come to the definition of what is equilibrium state. ठीक है. So what are the so it the three laws, the three generalizations can only be applied to certain situations which are called as equilibrium of the system. So it is very important to study this chapter because as a thermodynamics, why is it important? Because all the if you study a chemical reaction and you want to predict this, this is the science that will help you predict about the occurrence of the chemical reaction. Okay, because every chemical reaction requires certain conditions to be fulfilled from energy point of view. So this chapter, the importance is, it helps you predict the occurrence, maybe sometimes the speed of occurrence, spontaneity, कितनी जल्दी होगा या आराम से होगा या नहीं होगा. Okay, and then it also helps you. So one is prediction of occurrence. Okay, होगा कि नहीं होगा, and and that only happens when there is a set of conditions that are met. So occurrence may happen, but you will then evaluate some conditions before you can pass a judgment. Okay, so this chapter helps you understand those conditions that decide the occurrence of a, based on concept of energy. Energy of the system is increasing, energy of the system is decreasing. Now, how do we predict based on that? The second thing it tells you is the fact that what is the extent of reaction. Okay, so the extent of reaction can also be predicted. Again, it's another prediction number 2. So first is occurrence, second is कितना होगा, so किस extent तक जाएगा ये reaction. Okay, or before the equilibrium is attained. Final goal any reaction is equilibrium. खत्म हो गया जी, before equilibrium is attained. And we have already seen one word, equilibrium पे ही लगता है 3 laws. All the 3 laws of thermodynamics can be applied at equilibrium conditions. And so even when a reaction reaches a certain equilibrium, right, what is the extent, कितना रिएक्ट हो जाएंगी दो चीजें, क्या पूरी 100% रिएक्ट होके दोनों खत्म हो जाएंगी, या दोनों 50-50% रिएक्ट होंगी और आगे रिएक्ट नहीं कर पाएंगी और द रिएक्शन विल स्टॉप. Okay, so before it attains the product side attains an equilibrium. अब बन ही नहीं रहा, आपने दो रिएक्टेंट्स को डाला ड्रम के अंदर, वो रिएक्शन शुरू हुआ, आपने चेक करा, उसके बाद जो प्रोडक्ट है वो बन ही नहीं रहा, रुक गया. You'll say you attained equilibrium because you are no longer able to get any product, even though the reactants are available inside the drum or react condition जो भी है आपकी टेस्ट ट्यूब
ड्रम
है
में
जो
नहीं,
भी है.
मतलब एज अ कॉनिकल फ्लास्क.
हाँ, एनीथिंग लैब के कॉन्टेक्स्ट में, फैक्ट्री के कॉन्टेक्स्ट में, you will see the reaction is attained. Okay, and then it helps you deduce law of chemical equilibrium. Okay, law of chemical equilibrium is also derived from this. ठीक है,
वैसे तो इक्विलिब्रियम वाले चैप्टर में होगा ना.
हाँ, एक हमें सीखना पड़ेगा वहां पे, क्योंकि इसमें जो लास्ट टॉपिक है वो इस पे, ये इसकी नॉलेज पे डिपेंडेंट है. यू हैव टू नो दिस टू बी एबल टू डू गिब्स लॉ एंड ऑल दैट. ओके, तो ये पढ़ना पड़ता है हमको, थोड़ा सा आउट ऑफ कॉन्टेक्स्ट आ जाता है, बट ये पहले सिखाना चाहिए वो केमिकल काइनेटिक्स में कि व्हाट इज केमिकल इक्विलिब्रियम, हाउ टू यूज लॉग टेबल टू सॉल्व सच क्वेश्चंस, क्योंकि वो गिब्स एनर्जी वगैरह में लास्ट टॉपिक जो है हमारा वो यही है. बहुत सारे बच्चों का इसलिए छूट जाता है क्योंकि उनको उस चैप्टर का ये लॉ केमिकल इक्विलिब्रियम आता ही नहीं है. तो वी विल हैव टू डू दैट बिफोर वी आर एबल टू सॉल्व क्वेश्चंस ऑफ थर्मोडायनेमिक्स. दोस क्वेश्चंस जहाँ पे यूज होगा तो पहले वो पढ़ लेंगे, फिर ये पढ़ लेंगे. इजी होता है बड़ा, बट पता होना चाहिए, वेरी सिंपल. Now let's talk about some basic terms and conditions. Okay, some basic terms associated with these uh, concepts. So first term you heard me talk about, a system is in equilibrium. तो ये system है जी, और ये जो इसके बाहर जो भी चीज है, that is called as surrounding. So there are two things always involved. A system is there, and then there is a surrounding. So system is the part of the, जो हमारे चारों तरफ चीजें हैं, तो that part of the universe which is being looked at, being studied for the purpose of temperature, pressure, etc. Right? जो Charles law वैसे वगैरह पढ़ते हैं. So system is this, which contains the, where the chemical reaction may be happening, a gas may be undergoing expansion. So ये system है क्योंकि हम इसके temperature, इसके pressure के बारे में स्टडी कर रहे हैं. फोकस हमारा यहाँ पे. सो एनीथिंग अंडर योर फोकस फॉर द पर्पस ऑफ स्टडिंग What happens when the temperature changes? What happens to the system when the pressure changes, right? So that part of the universe is called as a system. So this is a system. Anything above that, outside of this system, is known as surrounding. That also belongs to universe. No big deal, right? So this is one basic definition. Surrounding को हम पढ़ेंगे, जरूरत होगी कभी कभी टेम्परेचर बाहर का बड़ा घटा देते हैं, तो क्या फर्क पड़ता है सिस्टम के ऊपर. All right, now let's talk about another situation where the so a system will also contain an amount of substance, reactants, gas, etc. Okay, so these, and तो हम तो बेसिकली फ्लास्क को ड्रम वगैरह बोल रहे हैं, बट दीज आर द बाउंड्रीज ऑफ अ सिस्टम. ये बाउंड्री है जिससे कोई ट्रांसफर नहीं हो रहा बाहर ना अंदर कुछ आ रहा है, और वो पढ़ते हैं कि what type of systems are available depending on the boundary it has. So second concept we have to understand is, if we are dealing with an open system, are we dealing with a closed system, or are we dealing with an isolated system? Okay. Open, closed system. These are the three types of systems. The first system we deal with is the open system. Now, when we talk about open system, a system is said to be open only if it can exchange through that boundary the matter and energy both. तो दोनों की लीकेज है, मैटर भी बाहर जा रहा है, धुआं जा रहा है बाहर, और एनर्जी भी जा रही है बाहर, गर्मी भी जा रही है, तो ये आ रही है, one and the same thing, right? So matter and energy both can be exchanged. For example, you have your floor. हमारे घर में जो फ्लोर होता है टाइल्स का, एसी चलाते हैं ठंडा हो जाता है, एब्जॉर्ब्स एनर्जी. पानी लीक हो जाएगा तो अंदर चला जाएगा. So that's boundary between air and the tile that is porous, and therefore we will say the system is open system. Easy example, daily life example to understand. And let's talk about a closed system. A closed system, so generally we will not see open systems. Numerical में कई बार लिखा होता है the test tube is open. तो आपको समझ जाना चाहिए कि जो एनर्जी के आपस में रिलेशनशिप है वो कौन से कैसे मैनिपुलेट करने, चेंज करने. अगर सिस्टम ओपन है और अगर सिस्टम क्लोज्ड है तो कौन सी वाली इक्वेशन लगानी है. तो रीड clearly in the numerical or question. So if the system can exchange energy, can exchange energy with the surrounding, right? But no matter, material नहीं बाहर आएगा जाएगा. You will call it a closed system. So no matter is going out or coming in. Energy is allowed, right? And then let's talk about the one we have already studied. For example, I'm not sure if you have, किसी को 12th के बच्चे को पढ़ाया था मैंने, तो which is the most important one for us. Thermodynamics में I think this is probably the most important one. Physics के thermodynamics में जब पढ़ते हैं, so this is what we generally deal with. Okay, so we deal with what is called as, so we are studying types of systems. So this is part B. We dealt with definitions, and now we are studying A, B, and C. So the third one we're dealing is the isolated system. Okay, isolated system. So if now isolated means system can neither exchange, neither can exchange matter, कुछ बाहर जाने भी नहीं वाला मैटर, तो लॉ ऑफ कंजर्वेशन ऑफ मास इज एप्लीकेबल, नॉर इट कैन एक्सचेंज एनर्जी. कुछ भी अलाउड नहीं है, दोनों नहीं कर सकते आप. थर्मस फ्लास्क, इफ यू हैव अ थर्मस फ्लास्क which keeps your water cold because no heat escapes from it. बाहर से insulated होता है, अंदर metal होता है, जो भी होता है, तो बाहर नहीं जा सकता कुछ भी, और कुछ nothing spills out. Water tight होता है बिल्कुल. So it's a very isolated type of system. So a thermos flask is a good example. Thermos flask. Okay, so we are dealing with the terms which we see, basic terms. The first term we've seen is system and surrounding, part of the system's universe. where we have a focus to study the effect of temperature and pressure. System, where we have no focus but surrounds the system, surrounding. So effect of temperature and pressure has to be studied with respect to a system generally. Surrounding का temperature पे क्या असर हुआ, etc. कोई फर्क नहीं पड़ता. Then we are studying some more terminologies like open, closed, isolated systems. One more very important, and again this is seen in physics, is the Haji said something.
No.
Okay, the background. Okay, anyway, so state function. Okay, so now physics has many quantities, etc. But any physical quantity, okay, if there is a physical quantity, mass is a physical quantity, temperature is a physical quantity, force is a physical quantity, physics, which is observable around us, it's physical. In the physical world, we can see it. Chapter number 1 of physics, physical world. Okay, Newton को भी physically दिखा था एप्पल गिर रहा है, so that physical quantity was gravity. Now the physical quantity in physics, or in the context of thermodynamics, we say it's basically a state function. Okay, किस state में आप हो उस हिसाब से वो value ले लेगी. अगर if the value of that quantity, if the value of that physical quantity depends on the initial and फाइनल स्टेट ऑफ द सिस्टम, मतलब एक फिजिकल क्वांटिटी और एक सिस्टम है. सो ये सिस्टम है और इस सिस्टम के अंदर कुछ फिजिकल क्वांटिटीज हैं, प्रेशर, टेम्परेचर, मतलब वगैरह वगैरह, वर्क डन, हीट एडेड, एक्सेट्रा. अगर वो क्वांटिटीज डिपेंड करती हैं सिर्फ इनिशियल स्टेट ऑफ द सिस्टम एंड द फाइनल स्टेट ऑफ द सिस्टम, टेम्परेचर बढ़ गया, स्टेट टेम्परेचर स्टेट बदल गई, so we will say that these quantities, okay, which are dependent on the only on the initial and final state of the system. So what is the initial state and what is the final state? तो calculate करा आपने, आपने देखा यार, I can move from my initial state to final state in multiple manners. I can go like this, 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 I can go like this. But irrespective of the way you change your system for a certain physical quantity, what you notice is कि अगर initial state और final state same ही रही, तो क्या रास्ता लिया unimportant है. Something very similar to vector displacement, कि distance जो मर्जी ले लिया, but displacement तो इतनी है ना, कैसे ही चले जाओ A to B, go like this, again displacement is same. Something very, so when the physical quantity behaves in a manner inside the system, maybe work done, maybe heat added, heat removed, temperature, something. But you find that initial and final condition of the system is same. This is same. We will say that that physical quantity, that वो जो physical quantity हम study कर रहे हैं, is a function of, is a state function. Okay, and if the so ये process है. Okay, this is a process. This is a process. There are thermodynamic processes through which you change the state of a system. You do some, you add a heat, you compress the system from here. You compress it. ये आपका piston है, यहाँ गैस भरी हुई है आपने, मैं फिजिक्स के वर्ड अभी से बता रहा हूँ, ये आपने प्रेस कर दिया इसको. Now this is an insulated wall here, so heat will not come, and you're doing work on it. So whatever work you do, right, when you compress it, gets added to the system. So this is a thermodynamic process. So पहले इनिशियल कंडीशन थी, बॉडी के पास कुछ एनर्जी थी, सिस्टम के पास, आपने वर्क डन करा, उसके अंदर और एनर्जी डाल दी, E+W पे आ गए. So your state has changed. Okay, but how you did work, whether what was your initial condition and then what's your final condition when you compress the gas and the gas volume has gone down, what way you did work, is sometimes important. If it is important that it depends on how you took it, right, then you will say that, for example, let's say energies which are physical quantities which are dependent on the initial and final only are, for example, easiest one is volume. Volume is but let's talk about uh, some other quantities we will. But right now, if you just consider volume के case में, what do you think? Is it a state function? Does it depend on? Does it depend कि आपने बाल्टी कैसे खाली करी है? I mean, if you
नहीं,
have a, so whether you took a tap and took out the water, or you took water through some other process, finally your water has come down from here to here, right? So volume is
वो
only
डिपेंड नहीं
dependent on.
करती वो
हाँ, नहीं
स्टेट
करती, तो
पे।
it's a state function, right?
वॉल्यूम तो
So
तब भी सेम रहेगी चाहे कहीं से भी निकालो।
exactly. So these quantities are state functions. Okay, they can ask you what define a
वर्क
uh,
और एनर्जी।
uh, when
वर्क।
when do you say a physical quantity is a state function? Bolo, when the physical quantity behaves in a certain manner, कि state of the system is changed from initial to final, and that is the only thing that matters to the physical quantity. Okay, it depends only on the uh, initial and has no dependence on the path taken. It has no dependence. So the value of the physical quantity is only dependent on initial and final, but has no dependence on the path taken to achieve the final state. We will say these type of physical quantities that depend on the initial state of the system and final state of the system. Let's label them as state function, and they have no relationship with the path taken. ठीक है? But if there is a situation where the state function is dependent on the route you take, okay, if the physical quantity is not independent of the path taken, depends on the path you have taken, then we are going to say that it is not a state function. So you dependence on path, if it is path dependent physical quantity, it's not a state function. If it's a independent of state function, it is a state function. So physical quantity,
इंडिपेंडेंट ऑफ स्टेट फंक्शन इज अ स्टेट फंक्शन व्हाट?
physical quantity is a is a state function. Physical quantity like volume is a state function because easy language mein, volume depends on initial and final state of the system, not on the process adopted to increase it or decrease it. So when I say the word state function, I mean it depends on initial and final state and is independent of the path taken. So physical quantities are state functions. Temperature is a state function because temperature only depends on the initial state and final state of the system, not on the path taken to change the temperature of the system.
और द वर्क डन भी।
Of course. But if you look at dissipative work, जैसे फिजिक्स में हमने पढ़ा था, वहां पे तो अगर रोड ज्यादा रफ हो गई, लंबी रफ हो गई, तो पाथ पे डिपेंडेंट होता है ना वो।
हाँ जी।
तो कंजर्वेटिव फोर्स एंड नॉन कंजर्वेटिव फोर्स, वो वाला फंडा है यहाँ पे। समथिंग वेरी सिमिलर। If you have friction here, it's negative work, right? So if you're coming with an energy of 10 joules, the loss due to friction is 2 joules. 8 जूल से बाहर आओगे आप, गया ना ये तो काम, lost. So friction will depend on your initial and final, but अगर मैं पाथ ऐसे बना दूं तो लंबा, ये वाला मेरा पाथ 2 मीटर का था, मैंने ऐसे 6 मीटर कर दिया और फ्रिक्शन वही रखा, तो क्या होगा? मोर लॉस विल बी देयर। तो पाथ डिपेंडेंट है ना फ्रिक्शन। सीधा जाने पे इतना लॉस है, फ्रिक्शन यहाँ पे भी है, इधर से जाओगे तो ज्यादा लॉस हो जाएगा, तो यू विल लूज मोर एनर्जी। सो फ्रिक्शन एज अ फिजिकल क्वांटिटी इज कंप्लीटली डिपेंडेंट ऑन पाथ टेकन। Whereas if you look into gravity, you take it from here to here a body, the potential energy, or you take it like this, potential energy remains same because it is only dependent on initial and final. H पे dependent होता है, path पे dependent नहीं होता। Made sense?
हाँ जी।
ठीक है। So when I say state function, I don't mean anything else except saying clearly this quantity is a state function. What I mean is that there is nothing new about it. It's a characteristic of the property. Whether the property has a character of being dependent on path or not. So we are not labeling quantities as in force is now called as force state function. No. It has a key characteristic. It behaves in a certain manner. That behavior is being expressed.
ठीक।
Fair enough. There are many, some you don't know. enthalpy and etc., which you will soon come to know. But for the time being, forget it.
आज
Okay.
तो कौन सा लॉ फर्स्ट लॉ करेगा आज?
और देखते हैं. If we can cover theoretically, then we will try to understand equilibrium. Then we will try to understand some properties, reversible, irreversible. I think you should first get acquainted with the terminology. Once you're very comfortable with terminology, it's very easy to teach you laws. Otherwise, you will get stuck. But hopefully, so that you know what is work, what is internal energy, what is this, what is this, what is this, पता होना चाहिए सारा before you enter the terrain of arena of laws. क्योंकि laws में जो language है, वो lingo बहुत अलग है. So get acquainted with that terms first. आज सिर्फ let's focus on terms, whether you can grasp the terms or not. You can see the number of terms is gradually increasing. ठीक है? So let's go to the next topic and let's discuss something like so macroscopic system and macroscopic properties. Okay, so there are two. One is extensive. The second is intensive. Okay, now what type of so every system has now let's come to a chemical system जिसमें chemicals हैं. So chemical के अंदर ion, molecule वगैरह वगैरह सब कुछ होता है, right? So all these constitute what is called as a macroscopic system. Macro level पे तो यही है ना, ion जी ions हैं, sulfuric acid ion है, ये है. तो all these chemical species which are atom ion molecules are called as the macroscopic system. Okay, so macroscopic system का क्या मतलब है? Ion molecule is an example of whatever is contained inside the system, right, is the macroscopic part of the system. And then every system has macroscopic macro का मतलब होता है large, just for your knowledge. Macro picture, बड़ी मोटी मोटी picture क्या है? तो मोटी मोटी picture है जी, system के अंदर molecules हैं, ions हैं. It's a big picture we're talking about, and obviously we are not going to deal with individual atoms because we're doing thermodynamics. Thermodynamics is more concerned with macroscopic view of the system. ये system है, इसके अंदर गैस है, इसका टेम्परेचर ही है. अब एक एक मॉलिक्यूल पे नहीं जाऊंगा मैं, ये मॉलिक्यूल क्या कर रहा है उससे मेरा कोई लेना देना नहीं इसके अंदर. जैसे broadly the system contains molecules of this and this, ions of this and this, and I will consider only macroscopic properties, which are also properties like volume, density. अब एक एक एटम की तो नहीं स्टडी करूंगा ना मैं, मेल्टिंग पॉइंट, बॉइलिंग पॉइंट, फलाना. So we have to be very careful that thermodynamics is going to deal with macroscopic picture of the system, not microscopic picture. जब kinetic energy gases पढ़ते हैं वहां पे थोड़ी microscopic picture आती है physics के अंदर. So when we talk about properties, there are extensive. Sorry, this is not a word associated with, I think, system. This is a word which is more connected to the world of macroscopic properties. Okay, there are two types. So extensive properties which depend upon the matter, the quantity of matter. Okay, so these are kitna maal hai andar, quantity of matter, those properties. Okay, the second type of properties which are available to you are based on the nature of matter. What qualitative, what type of matter is it? इसको उससे कोई फर्क नहीं पड़ता कि कितना मटेरियल है अंदर. So temperature, okay, pressure. Let's talk about pressure, temperature. So these are intensive properties of the system. It really doesn't matter how much quantity is there, but let's talk about extensive properties. For example, you know, तो जैसे I don't know, you have studied in 9th standard जब हम वो चैप्टर पढ़ते हैं वेपराइजेशन का, उसके अंदर एक वर्ड आता है हीट कैपेसिटी, लेटेंट हीट ऑफ वेपराइजेशन.
हाँ आते
ms थीटा, ms डेल्टा थीटा. कॉपर होता है, कैलोरीमेट्री होती है थोड़ी सी, और पानी होता है उसके अंदर, तो पानी भी गर्म हो जाता है और कॉपर भी गर्म हो जाता है. सो स्टफ लाइक दैट विच इज कंप्लीटली डिपेंडेंट ऑन हाउ मच यू मटेरियल यू हैव is known as the extensive properties. Okay, क्वांटिटी पे डिपेंडेंट होते हैं। गिब्स एनर्जी जैसे हम पढ़ेंगे वगैरह वगैरह, जो लेटर हमारी मेन एनर्जीज हैं, दे विल बी so mass is completely depends on the amount of material, right? Volume is completely dependent on how much material you have. जितना ज्यादा माल होगा उतनी ज्यादा वॉल्यूम होगी, सिंपल। तो simplistically speaking these, but when we will deal with the bigger properties like Gibbs energy and stuff like that, you will realize that all of them, the enthalpy, entropy and all of them are dependent completely on the uh, amount of material present, not on the nature of the material. So entropy, there are formulas of, but mainly they are extensive properties. So entropy is an example of enthalpy, etc. Is an example of extensive. Intensive properties are these basic pressure, temperature. So and these, you can't say temperature of anything depends on the quantity of when it comes to thermodynamics. Okay.
ठीक
Okay. And and then of course some quantities can become convert. For example, if I give you a situation of mole fraction, which we have already done. Okay, so let's say mole fraction is a ratio. It's a ratio of quantities. Why? Because it is same as the moles of the component.
ईटा ए अपॉन ईटा
हाँ,
ए प्लस ईटा बी।
right. Total number, right?
हाँ जी।
अब ये दोनों क्या है? Depends on material ना, कितना माल है, moles तो उससे निकलते हैं।
हाँ जी।
All components. ऊपर extensive properties है material dependent. But जो answer आता mole fraction, that is intensive. It has nothing to do with amount of material because it is a ratio.
ठीक।
Because it's a ratio.
ओके।
It doesn't depend on the amount of material present because it's a ratio. So two quantities getting mixed up. Okay, so okay, so volume is an extensive property or intensive property?
So volume is an extensive property.
Right. Give an example.
Example,
Hmm.
how it depends upon the quantity of matter.
Yes. So yeah, look at this box. Okay, this is your box.
Hmm.
If this is your box, you split it into two parts. ठीक है?
The
पहले V
volume
था,
gets
हाँ, so volume is what? V by 2, V by
half,
2, right?
half.
So could you change it? Same volume,
Uh,
right?
हाँ जी।
Temperature भी नहीं बदला, कुछ नहीं, partition डालने से. What does it show? That even after putting a barrier, you could not do anything. The volume becomes V by 2, V by 2. It is completely material dependent. आपने तो स्टेट बदलने की कोशिश करी है ना इसके बीच में वॉल्यूम डाल के, मतलब पार्टीशन डाल के।
स्टेट बदली नहीं।
हाँ, कुछ नहीं होता उससे। तो मतलब नेचर ऑफ द सब्सटेंस पे तो डिपेंडेंट नहीं है ना। इंटेंसिव प्रॉपर्टीज आर व्हाट विच आर डिपेंडेंट ऑन नेचर ऑफ द सब्सटेंस। नेचर से बदलती हैं, इससे नहीं बदलती। जो मैटर से वॉल्यूम तो एक ही तरीके से बदल सकते हैं ना, जब तक आप मैटर लीकेज कर दो, यहाँ पे रिलीज कर दो, दैट्स द ओनली वे यू कैन चेंज इट, बिकॉज इट इज कंप्लीटली डिपेंडेंट अमाउंट ऑफ मटेरियल प्रेजेंट। अगर एक गैस मॉलिक्यूल यहाँ पे है 11.2 लीटर, इसमें से कुछ लीक हो गया तो ही बदलेगा ना ये,
हाँ जी।
है ना। अगर आप किसी और चीज के डाल दो इसके अंदर गैस के, वो भी वी तो रहेगा
हम्म,
वॉल्यूम,
हाँ जी।
बिकॉज इट इज क्लोज ना, क्लोज्ड है। कैसे चेंज करोगे आप इसको? यू कांट चेंज द एक्सटेंसिव the property of the system, because the property of the system is I am having this volume. Now you can put hydrogen, you can put oxygen, you can put nitrogen in me, volume is going to remain same.
ठीक है।
पार्टीशन डालने से बड़ा थोड़ी ना हो जाएगा डब्बा, क्या हो जाएगा, छोटा भी नहीं होगा, सो इट रिमेन सेम, दोनों साइड पे आ जाएगा V by 2, V by 2, दैट्स ऑल।
ठीक है।
Why do you think force is an extensive property?
Force, it is an intensive।
Force, ध्यान से, so it is dependent on mass, friend.
मैं इंटेंसिव
हाँ,
इंटेंसिव ही तो बोला।
मास पे डिपेंडेंट है।
हाँ।
मास डिपेंडेंट प्रॉपर्टी है। व्हाट आर मास डिपेंडेंट प्रॉपर्टीज? क्वांटिटी पे डिपेंडेंट जो होती है। एक्सटेंसिव,
अच्छा।
ओ भाई, एक्सटेंसिव।
ओके।
प्रेशर,
वो भी एक्सटेंसिव होगी।
force upon area.
Extensive.
Note it down. So m into a रेशियो है ना,
हाँ जी.
फोर्स पर यूनिट एरिया.
Newton per meter square.
Yes. So it is a intensive.
Intensive या extensive?
प्रेशर.
प्रेशर ना एक्सटेंसिव नहीं होना चाहिए कि मास पे डिपेंडेंट है.
हाँ है तो सही, बट पर यूनिट एरिया है ना.
पर यूनिट एरिया तो मतलब नेचर ऑफ मैटर पे भी डिपेंड कर देगी.
नेचर में नहीं डिपेंड करेगी, ये नहीं बोल सकता मैं कि नेचर पे
तो
डिपेंडेंट है.
आपने बोला इंटेंसिव प्रॉपर्टी होती है जो नेचर पे डिपेंड करती है.
यस, बट ये सिचुएशन वो है जहाँ पे ये पक्का है कि सिर्फ मास डिपेंडेंट पर यूनिट एरिया बेसिस पे है. यू राइट कि इफ यू गो स्ट्रिक्टली बाय द डेफिनेशन देन यू आर करेक्ट कि प्रेशर को हमें इंटेंसिव में नहीं एक्सटेंसिव में डालना चाहिए, क्योंकि मास तो आ ही रहा है ना.
हम्म.
आ रहा है, अग्रीड. यस, but it is not a mass like a mass into acceleration. It is mass per unit area, like a uh, ratio. So is there so properties which are
Which have a ratio of fraction.
no, I don't think so. Let me just think कि uh,
एक्सेप्शन है ये.
ये एक्सेप्शन भी नहीं है यार. क्योंकि ऐसे तो कितनी एक्सेप्शन बन जाएगी.
केमिस्ट्री
मतलब
ऐसे
मैं नहीं नहीं एक
एक्सेप्शंस
सेकंड,
होगी.
नहीं let me just let me recalibrate this. Okay, so you have a gas. Okay, because हम क्योंकि ना फिजिक्स से कंफ्यूज कर रहे हैं थोड़ा. वैसे तो यहाँ पे हमने फिजिक्स ही यूज करी है, बट रिमेंबर इफ देर इज अ
प्रेशर इज.
gas chamber gas chamber, okay, let's say there is a gas chamber
ओके.
and there are molecules of hydrogen gases. Okay,
ठीक है.
now they collide with the chamber, and after the collision, it's an elastic collision, they come back. The change in the momentum is minus mv. Okay, so first the momentum was minus, and then there is minus 2 mv is the change. The contact time is delta t, so this is delta t, right? That's my rate of change of momentum of the
इम्पल्स और नहीं, इट इज फोर्स.
on the chamber also, equal and opposite reaction. So this is the force being experienced, not the force, this is a impulse being experienced by the molecule. And if I divide it by delta t, which I have, then it becomes the force on the
फोर्स
molecule. And the
और
same
शॉर्ट
force is
पीरियड ऑफ
therefore
टाइम.
transferred to the chamber also. So
ठीक
chamber
है.
is also feeling the same force.
फोर्स.
ठीक है? So
ठीक.
force, now what you do, you say that I am going to add more hydrogen inside this. Okay,
मोर
more
हाइड्रोजन.
hydrogen, yeah,
ओके.
more hydrogen molecules go. So more collisions happen.
ठीक है.
So the number of collisions total which sigma is there is higher, and therefore the force being felt is more. ठीक है? Just give me some. Yeah, I
ऑलराइट.
think something wrong with the. हो गया.
सर
Zoom
एक
has
मिनट पेन
lost.
की इंक थोड़ी मोटी कर लो.
नहीं बहुत मोटी करी हुई है. अभी तो कोई गड़बड़ हो गई इसमें. अभी रुको.
अच्छा रुक जाओ, आप ना एक काम करो, जब भी आप कुछ लिखना तो थोड़ा जूम कर लिया करो.
Okay, wait.
100% पे कर लो या फिर 75% पे. तो इंक थोड़ी मोटी दिखेगी आपको.
Okay. नहीं अभी तो कुछ और ही हो रहा है ये. Okay, गया. So I'm just thinking why pressure.
सर एक बार अपना स्टाइलस सेटअप दिखाओगे एक बार के उसमें.
हम्म मोबाइल से दिखा सकते हैं, और कोई तरीका नहीं है.
ऐसे लैपटॉप की स्क्रीन है थोड़ा सा ऊपर करके. चल.
Not possible. Because my camera is not laptop camera.
जैसे वेब कैम.
It's a webcam, Logitech C922. That's what I use. You will have to shut down this, open it again. Wait. इसको बंद करना पड़ेगा यार, ये अटक रहा है ये जूम को ना. यूएस में सुबह हो जाती है मुझे लगता है, तो वहाँ जूम अमेरिकन डेटा सेंटर में चालू हो जाता है. इंडियन इंस्टेंस तो है नहीं इनका कुछ. दे हैव नो इंडियन
यहाँ
इंस्टेंस.
में तो शायद नहीं, इनका जूम हेडक्वार्टर्स.
कुछ भी नहीं है. नथिंग. दे आर कंप्लीटली यूएस फोकस्ड कंपनी. कोई
बनाई
सपोर्ट
किसी
नहीं है, कोई
चिंकी
कॉल
नहीं
सेंटर.
थी.
हाँ.
बनाई तो किसी चाइनीज नहीं थी ये शायद.
अच्छा. ओके।
हाँ, एरिक युआन।
ओ,
चाइनीज, चाइना का था ये बंदा।
मतलब अमेरिकन चाइनीज, राइट? ये
चाइनीज
चाइनीज चाइन।
अमेरिकन। चाइनीज अमेरिकन।
ओके भाई।
बिजनेसमैन एंड अ इंजीनियर।
ओके, एक मिनट यार। All right. So now what we do, we add more gas to it, and then we see more force. Okay, so area remains the same. So number of collisions which are happening. So pressure on exerted by the gas molecules is dependent on. Let me show you the expression. Okay, what is a pressure due to gas? Okay, let me show you the expression so that I think we will be able to, maybe we will be able to appreciate why this is an extrinsic property, which means, sorry, intrinsic property, because it is dependent on the nature of material, maybe because of this explanation. Let me show you the formula of the pressure which is exerted by a gas when it is inside a chamber, and what formulas do come. All right, so this is okay. So the pressure comes out to be 1/3 rho c square. Let me show you the derivation of all what we're doing. The final pressure you will get is 1/3 of density of the gas and root mean square velocity. Okay, squares of all velocities, जितनी भी velocities हैं उनको नेगेटिव या पॉजिटिव है, उनको सबको पॉजिटिव में स्क्वायर करना है आपको. एंड one, so this is per unit volume. Okay, pressure, this is the pressure being experienced by the um, chamber. Okay, so this
चेम्बर।
is, yeah, so this is the value of the
रो
pressure
क्या
which
है?
is,
डेंसिटी, अच्छा।
yeah, density. Now
हाँ।
remember, if you change the gas,
ठीक है।
the density of every gas is different.
अच्छा, ओके, दैट्स व्हाई
केमिस्ट्री
इट
से
इज।
समझाना थोड़ा मुश्किल हो रहा है मुझे लग रहा है. यू राइट, केमिस्ट्री से हाउ डू एक्सप्लेन इट केमिस्ट्री. फिजिक्स इज इजियर बिकॉज ये काइनेटिक थ्योरी ऑफ गैसेस में हम पढ़ेंगे एक्सप्रेशन. सो दिस इज द वेलोसिटी जो हम यहाँ लिख रहे थे ना, v.
सी इज द वेलोसिटी ऑफ लाइट और समथिंग।
ऑल द मॉलिक्यूल्स, लेते हैं सारे के सारे चेंबर के अंदर, उनकी वेलोसिटी को c1 c2 c3 लिखते हैं, क्योंकि उनकी
अच्छा।
वेलोसिटीज नेगेटिव और पॉजिटिव भी होती है ना. एक ऐसे जा रहा है मॉलिक्यूल,
ओके।
तो एक ऐसे जा रहा है मॉलिक्यूल उल्टी साइड पे. आई डोंट नो व्हाट्स हैपनिंग यार, ये उल्टा जा रहा है. तो लॉट ऑफ पीपल विल से बोथ आर गोइंग इन ऑपोजिट डायरेक्शन, द नेट मोमेंटम इज जीरो, सो देयरफॉर देयर शुड बी नो pressure. But reality is, even though they're in opposite direction, wherever they go and collide, they do produce pressure. But impression which general impression could be, इसका mv है और उसका माइनस mv है, कोई मोमेंटम इज जीरो है सिस्टम का. तो
तो
ऐसा
जितनी
सिस्टम जो,
ज्यादा गैस की डेंसिटी उतना हाई प्रेशर।
हाँ, बट आई एम रेफरिंग टू द वेलोसिटी पार्ट नाउ. The velocity is not ordinary velocity, but is the square of even the negative velocities.
ओ,
C square of all the molecules average.
ठीक है।
We don't average plus and minus. We square negatives and then take the average.
ओके।
Okay. यार, just give me 1 second. I don't know what's happening. ये लाइनें अपनी आप आ रही हैं. I'm not doing any of this.
स्टाइलिश में गड़बड़ होगी।
नहीं नहीं, ये जूम की गड़बड़ है यार. हो जाती है कभी कभी क्लाउड में ये. और ज्यादा बोर्ड खोल लो तो specifically they will put you in so much trouble. Just give me 1 second here. Let me see
चले।
if there is an option to upgrade. Now this is becoming a pain now. Let me see if carrying my credit card. ये बहुत ज्यादा हो गया भाई. Wait, let me see if there's an option to upgrade. पूछ रहा है. Upgrade to unlimited whiteboards.
मुझे भी
You write. You try and write. See if you can write.
मेरा तो कुछ दिक्कत की बात नहीं है, मैं तो आराम से।
लिखना 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 लिखना.
क्या लिखूं मैं?
And write anything. अच्छा, you're
ओके।
able to write. कोई problem नहीं है तो ठीक है. The problem is from my side. Is having some trouble. हाँ, you're able to write. ये मैं बना ही नहीं रहा. ये these are getting made on their own. So anyway,
कि मैं स्क्रीन के ऊपर लिखता हूँ ना, आप स्टाइलस यूज कर रहे हैं राइटिंग पैड पे।
कोई मतलब नहीं उससे. Anyway, so pressure is a function of, you can see, density, right? Density is different, and therefore it is material dependent. It was easier to explain using this than that concept. Next concept and terminology you must know is the concept of thermodynamic equilibrium. Let me go to the next page. I think maybe this page is full or something. Yeah, likhne nahi de raha. Okay, so the concept of thermodynamic equi
तो वैसे एक बताओ, थर्मोडायनेमिक्स का नाम थर्मोडायनेमिक्स क्यों है?
मतलब
थर्मोडायनेमिक्स का नाम थर्मोडायनेमिक्स क्यों बोलते हैं इसको?
English.
हाँ.
So I think it's more to do with verb versus noun. When we say it's a chapter's name, we call it thermodynamics. And when it is in action, that means it shows something like equilibrium, we say it is thermodynamic equilibrium. Now it's not a name, na? It's a flow, it's a process. So we're studying thermodynamic equilibrium. Okay. Not the chapter of thermodynamic equilibrium, we're studying thermodynamics. Maybe something like that. I'm not sure. Okay. Now, what is the definition of thermodynamic equilibrium? A system is said to be in thermodynamic, right? This looks like a verb, right? कोई action है कुछ. Thermodynamic properties. Sorry, equilibrium. Yeah, we are studying condition of equilibrium. Said to be in thermodynamic equilibrium if it's the properties which are its like temperature, pressure, etc., which we just studied, are the state functions and are part of the extensive properties, macroscopic properties. Okay, macroscopic properties, temperature, volume, enthalpy वगैरह तो हम आगे पढ़ेंगे, Gibbs energy वगैरह वगैरह, right? They remain constant. Remain constant.
Why?
रुक जा. Throughout the process. Throughout the process, whatever process was done on the gas, heat addition, etc., etc. Okay, so these microscopic properties remain constant throughout the process and do not change with time. बदलती नहीं है time के साथ. Okay, so these all processes are called as so one is, what is the condition of equilibrium? It's a that तो condition of thermodynamic equilibrium होती किसकी है? System की होती है और किसी की नहीं होती. Okay, so you are studying somebody's in the universe, you're studying particular aspects, part of the universe which is called as system, जिसकी study करते हो आप. इसकी study करते हुए आप इसकी मैक्रोस्कोपिक प्रॉपर्टीज देखते हो, बदलती नहीं है, तो आप बोलोगे ये सिस्टम तो थर्मोडायनेमिक इक्विलिब्रियम में है. टाइम बीतता जा रहा है, हम कुछ कर भी रहे हैं, इसमें हीट ऐड कर रहे हैं, इसमें वर्क डन कर रहे हैं. जैसे मैंने बोला कि इंट्रोपी, इंथैल्पी पढ़ेंगे हम, तो हम कुछ कर रहे हैं सिस्टम के ऊपर, लेकिन हम देख रहे हैं उसके दौरान चेंज नहीं हो रही ये दीज मैक्रोस्कोपिक प्रॉपर्टीज. नथिंग, नो चेंज इज हैपनिंग टू देम. नाउ सो यू से व्हाई. Okay, so there are different processes due to which it happens. So the first very important process is the isothermal process. मुझे नहीं लगता we will go deep inside these processes like we do in physics. So there is something called as an isothermal process. It's a thermodynamic process. Okay, during this isothermal process, so it is a thermodynamic process. पक्का ये thermodynamic process है. Okay, but हमने लिखा system is said to be in thermodynamic equilibrium. Now, when we say it is it's a isothermal process is being carried out. It is being carried out in a way that temperature is going to remain constant. ये याद रखना है. Thermo isothermal process is a process जो होते हुए सिस्टम का टेम्परेचर नहीं बदलता.
ठीक है.
Temperature is going to remain constant during such processes. So there is a way we organize the process. कुछ हम करते हैं कि ये टेम्परेचर चेंज नहीं हो पाता सिस्टम का चाहने के बावजूद भी, हमें कुछ करना पड़ता है उसके अंदर. ठीक है. सो वी विल डिस्कस दोस थिंग्स. So what will happen, even though system may be increasing its heat because of that process, this process, but temperature फिर भी नहीं बदल रहा. क्या है? तो we do some interactions with the surrounding to keep it intact. Maybe we are trying to हीट पैदा हुई और हमने इस सिस्टम को क्लोज सिस्टम बनाया, आइसोलेटेड नहीं रखा. क्लोज सिस्टम होने की वजह से हीट एस्केप कर गई तो टेम्परेचर बढ़ ही नहीं पाया. आप इसके ऊपर वर्क डन कर रहे हो ऐसे और कंप्रेस कर रहे हो गैस को. अगर आप सिस्टम को आइसोलेटेड रखते हो तो कंप्रेस करोगे तो अंदर टेम्परेचर बढ़ेगा, क्योंकि हीट एस्केप नहीं हो सकती तो टेम्परेचर बढ़ जाएगा. हीट इज अ वन दैट रिजल्ट्स इन इंक्रीज ऑफ टेम्परेचर. बट आपने क्या करा? व्हाट यू डू इज यू क्रिएट दिस एंड मेक दिस a closed system, not an isolated system. So मैटर तो बाहर नहीं जा रहा, बट हीट एस्केप अलाउड है. तो आपने चारों तरफ इंजन के या जो भी आपने कंप्रेसर और पिस्टन और सिलेंडर लिया, आपने कंप्रेस करना शुरू करा, लेकिन हीट अलाउ कर दी. बाहर से जो एडियाबैटिक जैकेट है, हीट कंटेनिंग जैकेट, मतलब no heat can is exchangeable with between surrounding and system. So there is a cover which is called as adiabatic cover, which is insulator for heat. जैसे हमारे घर में ईंटें होती है, मकान बनते हैं, तो हीट इधर से उधर बहुत कम जा सकती है. लेकिन अगर घटिया क्वालिटी की कंस्ट्रक्शन और बैड क्वालिटी ऑफ कंस्ट्रक्शन हो, सो हीट कैन कम इनसाइड एंड देयरफॉर यू मे फील हीट coming from the walls. Obviously radiation is also involved, but that is more of sun rays transferring the heat. But if the heat gets started getting transferred through the walls to your house, then that is a process which is not adiabatic. So we put a lot of stuff inside the wall in other countries so that cold ठंडी हवा अंदर ना आ जाए, ठंड अंदर ना आ जाए. So we make it insulated. So we say we have this a jacket we have created called as an adiabatic jacket, which in simple English means insulator. Does not allow heat to go. Rajai, when you sleep in winters wearing that, what happens? Your body heat cannot escape through that, and therefore it acts like a adiabatic jacket on you. The heat cannot escape from you, right? So similarly, isothermal process, on the contrary, heat can escape. So heat escapes, and therefore if you do work on the system and add more heat, though you may feel temperature बढ़ना चाहिए अंदर, temperature नहीं बदलता, क्योंकि the heat escapes, the heat is escaping, and therefore it is not possible for you to increase the temperature. And similarly, if you open, as in expand the system, so you pick up the piston and you take it up, now the gas is pushing, which means the gas is doing work. So gas will lose its energy in doing this work, and therefore the energy of the gas will come down, and you will say, okay, the energy of the gas has come down, so its temperature गिर जाएगा. But then as soon as it becomes lower, the temperature of the surrounding becomes higher, and heat escapes from surrounding to the system, and the temperature is restored. So फिर से नहीं बदला. So there are ways you can maintain isothermal process, but key point, the temperature does not change. How you do that? But most likely allowing most likely मतलब 100% heat is allowed to escape, and heat is also allowed to enter. Both are allowed in this. ठीक है? Second type of thermodynamic process, which I've already explained to you a bit, adiabatic process. Now, adiabatic process, you don't allow any heat exchange to take place, no matter. So adiabatic processes deal with an isolated system. No heat exchange, no matter exchange. This deals with a closed system. Heat is allowed. It's not an isolated system. So if I do the same thing, I now apply work on this, compress the gas. My work gets added to the gas. अभी मैं केमिकल के पॉइंट ऑफ व्यू से नहीं बता रहा, मैं गैस और सिस्टम ऐसे बता रहा हूँ. ये दबाया और ये your work has got added here and the heat has gone up, but you have an adiabatic jacket around it, so no heat can escape. So all the work you did went to increase the energy of the system, and therefore you will see that this system is at higher temperature. So this is not a isothermal process because the heat cannot come in and leave. Such processes in which adiabatic processes in which the heat Q cannot escape or come inside or come inside. Isothermal it cannot escape or leave, come inside, are called as adiabatic processes. So adiabatic processes will not be able to maintain temperature. They are not isothermal processes, right? Because of the complete insulation of the system. So you are completely insulated with the help of an adiabatic jacket or some insulating material, stuff like that. इसके लिए भी you have to do an experiment. We are putting a jacket around it and something like that. So adiabatic process clear हुआ? Heat नहीं allow करोगे, temperature change हो सकता है.
ठीक.
Okay, let's come to the next one. These are very simple terminologies, but very good to know because they help you in your class 11 physics also. Repeatable है सारी की सारी. Identical चल रहा है, अभी तक physics ही चल रही है. कुछ खास आया नहीं है जो chemistry में directly categorize करा जा सकता है.
ठीक.
थर्ड, क्योंकि लॉ भी नहीं पढ़ा अभी हमने केमिस्ट्री के पॉइंट ऑफ व्यू से. थर्ड प्रोसेस इज कॉल्ड एज आइसोकोरिक प्रोसेस.
आइसोकोरिक.
कोरिक,
नाम.
yes. So
क्या
isocoric
भारी नाम है.
process are the thermodynamic process in which the volume remains constant.
ओके.
Remains constant. I don't know, these are Latin words or what are these words. So volume of the system remains constant. Volume of the system. And let's come to the next one. It is called isobaric process.
और
When the pressure of the system is kept constant. Most of the processes we do in daily life are isobaric because हमारा दूध उबलता है तो हम प्रेशर तो नहीं बदलते ना, एटमॉस्फेयर का सेम ही रहता है. खाना बनता है, जो खाना तो खैर अगर कुकर में बनेगा तो यू आर changing the pressure, but generally most of the processes which are biological processes, breathing and all, everything is happening at the as a isobaric process. Okay, heat exchange, everything is happening, but the conditions of the experiment are फूल जो है वो एनर्जी बना रहा है using chlorophyll and all that, sun energy and all that. It's isobaric. Pressure does not change. Okay, so these are the systems, sorry, the processes in which the pressure of the system, फिर हो गया शुरू तंग करना, anyway, remains constant. Oof. Hit. इतना तो नहीं लिख दिया था कि फिर से तंग कर रहे हैं. So 4 processes. Name them. Isothermal, adiabatic, isocoric, isobaric. Bar is a very good hint for you to know. Baric. Bar is a unit of pressure. 1 bar, 2 bar. Isobaric.
ठीक है. Pressure doesn't change.
No.
Pressure remains same.
Yes. Throughout the process. And thermodynamic processes deal with what? They deal with energy and their exchanges only. तो जब मैं बोलता हूँ थर्मोडायनेमिक प्रोसेस तो मैं कोई ऐसी कोई क्वांटिटी नहीं बोल रहा, मोमेंटम. आई एम वेरी क्लियर, आई एम डीलिंग विद एनर्जी एंड द क्वांटिटेटिव रिलेशनशिप बिटवीन दोज हीट्स, energy exchanges. Okay, let's say so okay, where were we were on the page number, all right. Pressure of the system remains constant. Generally when we study these processes, let's cool down for a. So generally, 1 minute रुक जाओ जरा. So generally when we deal with these processes, we are dealing with the pressure versus volume graph. to explain these processes. तो pressure versus volume graph use होता है. Pressure of the system, temperature of the system, macroscopic system, not microscopic system. मतलब एक एक मॉलिक्यूल की स्टडी करनी नहीं इसके अंदर. Tell me if you can see the screen.
हाँ जी.
Have I shared the screen now?
No, you're not.
है ना भाई, I'm just wondering how can you see it? क्योंकि वो थोड़ा रुक रुक के हो रहा है. I think it's causing pain now. Okay? हाँ जी. All right. So let's say we draw a pressure versus volume graph of pressure versus volume. ठीक है? Pressure versus volume. So this is pressure of the system. So if you draw a diagram, why do we study pressure versus volume? There is a specific reason. The area under a pressure volume graph actually is work done in thermodynamics, physics. PdV integral. Okay, generally this is the way we calculate. होता तो dV by dP into V भी होता है, because work done का formula actually is derivative of P into V लिखते हैं. But ठीक है. और generally the systems are the volume changes in the work done. When the volume changes, pressure may be given as V square. So V square dV, some relationship between pressure and volume. So P versus V graph is studied because that's a very good explanation to explain these processes. So let me show you what happens from work perspective, and take it that change in volume, okay, a dV is responsible for work done by the system, expansion, work done on the system, compression of the system. When I say system, I'm dealing with only a gas chamber, which is this, and has a piston on top of it, and there is you can compress it or you can expand it. That's all. And if you talk about this pressure versus volume, let's say first process I've drawn is isobaric process. Okay, isobaric. Now remember, in an isobaric process, the pressure remains constant. And if you assume you don't know too much about it, but work done is given by pressure into change in volume. And this is no brainer because work done is actually force into displacement, if you remember. Okay. And if you consider this to be the situation, okay, this is for example, I compress this by giving work on top of it. I compress it by an amount of length is, for example, the displacement of this is dx. So my work done will be F into the displacement dx. And then I can divide and multiply this by area. Okay, divide and multiply by area. If I do that, this part becomes a small change in the volume, dV. Okay, this is my dV, and this force upon area becomes pressure. So pressure into change in volume is the small amount of work done. So work done is generally, for your purpose, all practical purpose, abhi ke liye, its change in volume is associated. Now look at isobaric process, which is a process where the pressure remains constant. You can see the volume has changed from here to, okay, when I'm referring to the isobaric process, I mean this one, not the vertical line. This is my isobaric process. My pressure has remained constant. So I have covered volume from here. इसके corresponding ये volume है और ये वाला volume है. Okay, so it's a straight line. So volume is from V1 to V2, and the calculation of work done is pressure is constant into change in volume, V2 minus V1. So in an isobaric, pressure is constant throughout this expansion phase, which is increase in volume. Therefore, the work done is this. So it's an expansion work. The system has lost work, energy, because it had to do some work. Now, let's talk about another situation, which is isochoric. So volume remains constant, but I'm decreasing the pressure also. Okay, I'm decreasing the pressure. Expansion ही होगी एक तरह से. If you see, the volume doesn't change. So there is no area under the graph. But if you look at isobaric, there is an area under the graph. ये isobaric का अच्छा खासा area under the graph है. But isochoric के अंदर, this is isochoric, and isochoric has no area under it, and therefore it's a straight line. So no work done. Work done in isochoric is 0. Okay. Now let's talk about another situation, isothermal. In isothermal, though you don't know physics, but I'll just show you. ऐसे behavior होता है. Curve आता है, and there is some area under it, right? So there is some work done. If there is an expansion, the system has lost energy, and that there is a formula of pressure and V, which is linked to each other, and you can calculate the work done. There's a formula, nRT, I think log V2 minus V1 by V1, some number of moles of the gas constant, temperature, because it's isothermal. This line is called as an isotherm line. This is a line where the pressure and volume both are changing, but the temperature is not changing. Same way, if you go with about adiabatic and you do the same thing, where you start the pressure and you end at the same volume, the work done is slightly less. ये जो नीचे वाला area आ रहा है, that is under the let me just show you the orange area. This orange area is the adiabatic work. एक गैस को इंसुलेट कर दिया और काम करा तो ऑरेंज वाला आया. अगर इंसुलेट नहीं करा और एनर्जी का एस्केप अलाउ करा, आइसोथर्मल प्रोसेस रखा, तो ऊपर वाला वर्क भी ऐड कर देना जो छोटा सा नजर आ रहा है, एक्स्ट्रा, which I can use some other color to show. So this is the extra work which is being done if you keep the same process as isothermal. So pink plus green total together constitute the isothermal work. You don't have to worry about details of this. Point being made is all four processes have a different behavior. We have seen one behavior which is work done. We don't need to get into detail of this. What we can easily see that wherever there is an area under the curve, there is a work done. If there is no area under the curve, there is no work done. So adiabatic में भी work done है. There is an area being covered. And for adiabatic, there are equations available, which you will study later, not in physics, but in not in chemistry, but physics. So ये आपकी adiabatic curve है. Okay, adiabatic line. This is isotherm, same temperature. So whenever you see these graphs, you just see them with a pinch of salt. कि I know something, कि समझ में आ रहा है मुझे. ये 4 प्रोसेस होते हैं और इनको पीवी डायग्राम पे सबसे इंपॉर्टेंट इनके बारे में जो स्टडी करा जाता है, वर्क डन. Obviously, how much heat I am adding. If I put a burner here, okay, I transfer the heat. I am adding some heat also, and it is expanding, so it is losing heat in form of work done. Overall, it has gas molecules also, which are moving randomly, and these molecules have something called as an internal energy, which is function of temperature. So we will study about work done, heat added, subtracted, and what's happening to the molecules when the temperature is going up and down. We will connect all these 3 quantities later when we study them in physics. Also in chemistry also we will link them, but we are not going to get into details of these processes in chemistry. नहीं करना हमें ये. मोटा मोटा we will do कि हैं processes, जितनी जरूरत है इतना काफी है कि there are 4 types of processes available in chemistry or physics irrespective. ठीक है? Okay, true or false? An isothermal process requires conducting walls of the system. That means it should be able to conduct energy. True or false?
True.
Isothermal, true. Yes. True or false? Adiabatic walls require an adiabatic jacket or non-conducting material to surround
False.
it.
False.
Non-conducting.
True.
True. Yes, they need not conducting. If you don't keep it non-conducting, it can't be adiabatic because true or false? Adiabatic processes result in increase in temperature if the heat is added to the system.
No, false.
Why?
Because adiabatic तो heat allow ही करते ना.
Allow ही नहीं करती है. तो my assertion is wrong, my reasoning is wrong.
क्या sir?
My reasoning is wrong, my assertion is wrong, ना? I can't add heat. Temperature तो दूर की बात है ना. I can't do anything.
मुझे लगा कि मेरा गलत था।
No, you're right.
हाँ।
You're right. I'm just converting into a reasoning assertion. बाद में करेंगे. Just giving you sample. Okay. In an isochoric process, the volume remains constant. True or false?
ट्रू।
Correct. तो इससे याद हो जाएगा. First, get acquainted with the jargon of this chapter before we jump into the uh, laws. हाँ, नहीं करना बहुत मुश्किल है. समझ नहीं आएगा law वो. All right. Let's talk about reversible. Now, what is this new spelling of reversible I've created? नया कुछ लिख दिया था, सिग्नेचर थे कि रिवर्सिबल था. मैं भी सोच में पड़ा था, मैंने अपनी साइन तो नहीं कर दिया कहीं गलती से. रिवर्सिबल देखो, लेकिन हमारा प्रोसेस रिवर्सिबल था.
ठीक
ओके, सो
है।
आवर प्रोसेस
ये
वाज
अच्छा था।
रिवर्स. रिवर्सिबल तो नहीं था भाई. Irreversible process. Okay, so another category apart from the thermodynamics part of it. So there are processes can be categorized as irreversible and reversible process. So if you do a thermodynamic process, I told you there are certain ways you have to do it. Okay, to maintain. But broadly पहले तो हमने conducting versus non-conducting पढ़ा है. But एक और बात होती है जो thermodynamics के reversible processes होते हैं. Okay, reversible processes. These processes are generally done in a very slow manner. बहुत स्लो वॉल्यूम एक्सपेंशन होती है, बहुत स्लो चेंजेस करे जाते हैं इनके अंदर. So they're characterized by what? They're characterized by एक इंग्लिश का वर्ड होता है which is generally used in, I have not seen it being used in too many places, but most of the time in physics and chemistry. Infinitesimally, बहुत छोटा मतलब डेरिवेटिव टाइप का, डेल्टा टाइप का,
एंड
स्लोली.
इनफिनिटली। वाह, क्या स्पेलिंग है।
बहुत ही. INFINITES सही है. ओके, सो दिस इज TES, दिस इज FINI.
ठीक।
इनफाइनेटेसिमली स्लोली होते हैं. एंड ओके, सो की कैरेक्टरिस्टिक infinitesimally slow. Okay, and the reason is if you do something very slowly, you have an opportunity to reverse it. If you do it something very suddenly, very fast, you don't have an opportunity to uh, do it fast. Sorry, reverse it. If you do something very slowly, this is what happens. That you for example, have a conducting valve with, this is your piston and this is your cylinder in which piston is there. Pichkari hoti hai jaise, something like that. Okay, now this is your gas particle. And what do? You compress it very slow, like this. बड़ा स्लोली आपने इसको कंप्रेस करा, थोड़ा सा. और तो क्या होगा, थोड़े कंप्रेस करने के बाद इट विल एक्वायर इक्विलिब्रियम विद द सराउंडिंग.
ओके।
दोनों का टेम्परेचर बराबर हो गया, दोनों का कुछ बराबर हो गया, कुछ प्रॉपर्टीज बराबर हो गई. सो अ रिवर्सिबल सिस्टम इज इन इक्विलिब्रियम विद इट्स सराउंडिंग.
ठीक है।
It is slow helps it reverse it itself, and then it is in equilibrium with the surrounding. Let's compare this to irreversible process. What is an irreversible process? The process which cannot be carried out slow. You cannot do this process at it has to be carried out very rapidly. ठीक है? There is no choice. And if you do the successive steps, which is small delta something you do, you cannot retract it, cannot be retraced, cannot be reversed, cannot be retracted. It's as simple as that. नहीं जाएगा वापस. ठीक है जी? Okay.
ओके।
And what else? and it cannot since it keeps on changing so rapidly, it can never be in equilibrium with something else. So it's never in equilibrium with the surrounding.
Okay.
All right. Any doubt in the definitions?
No, sir.
Okay.
Simple thing.
So there is a chart available where you have to memorize the difference between a reversible process versus
मैं
irreversible
अभी शायद
process.
जितनी भी डेफिनेशंस तो अपने कराई आज क्लास में मेमोराइज कर दूँ.
If you don't do this, then you will find it very difficult to do this chapter. बहुत सारी हैं और ये आना बहुत जरूरी है. कुछ ऐसे चैप्टर आते हैं जहाँ डेफिनेशन ही बहुत इंपॉर्टेंट होती है क्योंकि द स्ट्रगल इज द लैंग्वेज इन द क्वेश्चन इज इट्स अ रिवर्सिबल, इरिवर्सिबल, अडियाबैटिक, आइसोथर्मल, मैक्रोस्कोपिक प्रॉपर्टी, दिस एक्सटेंसिव. तो बंदा उसमें याद नहीं रखता तो उसे करना नहीं आता. होता सिंपल है, but the new language is very alien to students in thermodynamics, so it's
ये भी तो कुछ ऐसे सिस्टम ऑफ पार्टिकल्स के अंदर.
उतना डिफिकल्ट नहीं है. ये बहुत इजी है. मेरे को तो बहुत मतलब आई फाइंड इट वेरी एक्स्ट्राऑर्डिनरली एलिमेंट्री टाइप ऑफ चैप्टर. बहुत ही इजी है. काइनेमेटिक्स के लेवल का चैप्टर है ये.
हैं?
उतना ही आसान लगता है और क्या. और देयर इज
अच्छा,
नथिंग इन इट.
काइनेमेटिक्स लेवल का है
हाँ,
फिर
आई
ठीक है.
फाइंड इट दैट लेवल. थोड़ा सा इसमें थोड़ा सा आता है पैची फेस जहाँ पे थोड़ा सा है, बाकी तो इट्स काइनेमेटिक्स. व्हाट इज देयर इन दिस एक्सचेंज ऑफ हीट, हीट फॉर्मेशन, दिस दैट, और क्या है इसके अंदर. आई फाइंड इट जस्ट प्योर मैथ्स एंड नथिंग एल्स. एक डेफिनेशन अगर आपको आ जाती है
जैसे
एंट्रोपी
सम
क्या होती
बेसिक
है.
कॉन्सेप्ट ऑफ केमिस्ट्री था.
हाँ, वैसा ही है ये. तो बेसिक कॉन्सेप्ट्स ऑफ एनर्जी है इसके अंदर, केमिकल एनर्जी, एंट्रोपी ऑफ द सिस्टम की डेफिनेशन आती है, इंथैल्पी आती है, और एक चार्ट याद कर लिया, हो गया. ये भाई इस सिचुएशन में इसको यूज
उससे
करना
एक
है,
वो
इसको ही
होगा
करना है.
कहते केमिकल इक्विलिब्रियम, गिब्स वाला.
एक पार्ट है बस. वो आउट ऑफ कॉन्टेक्स्ट हो जाता है. वो सीख लेंगे तो वो भी कर लेंगे, कोई दिक्कत नहीं है उसके अंदर. दैट आई विल टीच, नथिंग टू वरी. सो लेट्स कम बैक. सो रिवर्सिबल सिस्टम
ओके.
and irreversible. Okay, so I'm not going to write the whole thing. So this is irreversible system. So okay, system carried out very slow, reversible very slow. किधर टिक में लगाऊं? Very slow, reversible or irreversible? Infinitesimally slow. इधर टिक
इनफैक्ट
लगाऊं या इस पे लगाऊं?
इरिवर्सिबल.
Infinitesimally slow, reversible. Correct.
रिवर्सिबल.
पहला पॉइंट. दूसरा पॉइंट, equilibrium never disturbed with the surrounding.
क्या क्या?
Equilibrium
हाँ.
not disturbed with the surrounding. It stays in equilibrium with the surrounding, not disturbed.
रिवर्सिबल.
Correct. सारे इसी की क्वालिटीज होती हैं. नेक्स्ट, लेट्स से takes infinite time to complete. हाँ, बहुत स्लो स्लो होता है. Takes infinite time to complete.
मतलब 100 साल.
Very slow. हाँ, नहीं, not madam. Why not? Why too slow? That's a point being made. Okay, too much time. Time के point of view से. Again, reversible, right? Infinitesimally slow तो यही है ना. So it will take too much time. And one very important point, which is the key, the work obtained. So if you do a process which is reversible, it is very similar, by the way, to the conservative force concept, because in that also the energy becomes reversible. So work you get from these systems is maximum work output they give, because energy gets converted into, these don't. Work is not maximum. The work you get from them is not maximum. ये बहुत की पॉइंट है. बाकी तो स्पीड पे था, बट ये एक सडनली पॉइंट आया विच इज स्लाइटली डिफरेंट फ्रॉम वर्क परस्पेक्टिव. हाउ डू दे बिहेव? वर्क डन बाय अ रिवर्सिबल प्रोसेस versus the work done by the irreversible process. ठीक है? All right. Let's move on. So we will do an explanation of this later. Right now, just this is more memorization. why the work by the reversible process is maximum, why the work is not maximum for irreversible. We will do the reasoning. अभी नहीं आएगी, जब आएगी we will do it. Let's do this. Some more quantities which you need to understand. And now we're getting gradually moving towards the laws, but still slightly distant. Okay, so first very important quantity which is pertaining to the laws is the internal energy.
ठीक है.
Now, when you say internal energy of the system, um, तो so these are the हम बोलते हैं ना कि भी इस चैप्टर में हम एनर्जी एक्सचेंजेस के बारे में बात करेंगे,
हाँ जी.
और दिस ओनली डील्स विद एनर्जी. वो कौन कौन सी एनर्जीज हैं जो एक्सचेंज करेंगी आपस में, हीट को या एनर्जी को एक्सचेंज करेंगी. एक है इंटरनल एनर्जी. सो you will find that you have these quantities heat, work, enthalpy, entropy. इस चैप्टर में आएंगी. फ्री एनर्जी भी एक वर्ड आएगा इसके अंदर, राइट, गिब्स में. तो वो जो ये सारी जो क्वांटिटीज हैं ये आपस में कैसे लिंक होंगी, इनकी एग्जैक्ट डेफिनेशंस क्या है, what do they mean? So the first you always deal with is the internal energy, and it is more to do with the any process can have this chemical or physical process, so कोई फर्क नहीं पड़ता उससे. और जो ये वाली एनर्जी है, it is completely dependent on the is it dependent on the nature of substance or not? Yeah, it is, I think, dependent on the substance, yes. क्योंकि ये जो इंटरनल जो वर्ड है ना, द वर्ड इंटरनल, एक्चुअली जो जो केमिकल बॉन्ड्स होते हैं उनके अंदर जो एनर्जी होती है, बॉन्ड एनर्जी, द एनर्जी गेट्स रिलीज्ड व्हेन द बॉन्ड्स आर फॉर्म्ड. इफ यू रिमेंबर, हमने केमिकल बॉन्डिंग में पढ़ा था. बॉन्डिंग हैपेंस, द सिस्टम loses energy and bonds get created, right? The energy which is stored in the bonds is called as the केमिकल बॉन्ड एनर्जी. और न्यूक्लियस के अंदर जो होती है न्यूक्लियर एनर्जी. तो ये सारी एनर्जीज जो है, न्यूक्लियर एनर्जीज, बॉन्ड एनर्जी और जो इलेक्ट्रॉन्स की एनर्जी, ये सारी एनर्जी, पोटेंशियल एनर्जी ऑफ द इलेक्ट्रॉन एंड द काइनेटिक एनर्जी ऑफ द इलेक्ट्रॉन, जो हमने बोहर में सारा पढ़ा है, ऑल दीज एनर्जीज टुगेदर कॉन्स्टिट्यूट व्हाट इज कॉल्ड एज द इंटरनल एनर्जी. एंड तो मतलब अंदर छुपी होती है, दिखती नहीं है, दिखती नहीं. It's not visible like a heat. If you touch it, you will feel it. You don't feel. This is hidden energy in the system. Okay, so these are the internal energy, which is sum of the chemical bond energy. Okay, chemical bond energy. It is the electron energy. It is the nuclear energy. It is the kinetic energy of the electrons. It is the potential energy of the electrons. Because it potential, when I say potential, when it's attract electrostatic charge है nucleus और चारों तरफ इलेक्ट्रॉन घूम रहे हैं, तो ये जो अट्रैक्शन की फोर्स है इनके बीच में, द एनर्जी ड्यू टू दैट विच होल्ड्स द, सो पोटेंशियल एनर्जी नेगेटिव होती है. काइनेटिक एनर्जी होती है, वो फॉर्मूला होता है 13.6. ओके, इलेक्ट्रॉन वोल्ट्स वाला. सो केमिकल, so all these hidden energies of the molecule or the gas is known as the total internal energy of the system and is represented by U or E.
ठीक है.
Okay, so in physics, when we study this, we don't get to this level. We just say कि every molecule has three motions. One is a translatory motion. That means it travels linearly, like this.
ठीक है.
Then there is something called as so oscillatory motion, simple harmonic motion, vibration, जिसको vibration बोलते हैं. Okay, so ऐसे ऐसे हिलना. एक होता है linearly चलना. फिर साथ में वाइब्रेट भी करते हैं मॉलिक्यूल्स. ओके, सो द वाइब्रेटरी मोशन, oscillatory or vibratory, that all, because of that also you have energy because of this vibration. The third type of motion which atoms and molecules or ions have is the rotational motion. So all these three combined together have this energy: translatory energy, kinetic energy, oscillation energy, vibratory is also kinetic, and rotation is because of the half I omega square or circular motion, जो भी कहना चाहते हो. All these three also constitute the internal energy. So why at the end of the day they exist is because of these. पीछे से यही है सब कुछ. तो फिजिक्स वाले they will call it translatory, oscillatory, rotational. Chemical bond वाले they will say chemical bond, electron energy, you know, one and the same thing, and it is still the internal energy. ठीक है? All right.
ठीक है.
So now if you see the behavior of this type of energy, and then you think in terms of chemical reaction, you know, तो पहले bonds थे, लेफ्ट साइड पे बॉन्डिंग थी, यू नो, NaOH प्लस HCl. तो NaOH के अंदर अपने बॉन्ड थे, HCl के अंदर अपने बॉन्ड थे. अब NaCl बन गया, वाटर बन गया, इनके अपने बॉन्ड्स हैं, राइट. सो दीज आर ऑल न्यूक्लियस बदल गया और नए केमिकल बन गए. तो दोनों साइड कुछ चेंज हो गया. माने जो एनर्जी, इंटरनल एनर्जी छुपी हुई थी रिएक्टेंट साइड पे और जो प्रोडक्ट साइड है उसमें अंतर आ गया. सो देयर इज अ चेंज इन इंटरनल एनर्जी व्हिच हैपेंड बिकॉज ऑफ द केमिकल रिएक्शन. And it is not possible to measure this directly. As you can see, you cannot go molecule by molecule and measure the internal energy. Obviously, temperature के ऊपर फॉर्मूले होते हैं फिजिक्स के अंदर. You can calculate the internal energy of every molecule. It is given by half kT. K is the Boltzmann constant. ऐसे लिख देते हैं बस उसको, half kT. Okay, half kT. So एक dimension x axis में इतना है, y axis में भी इतना ही है, और z axis में भी इतना ही है. तो every molecule has a 3/2 kT. So there they show that internal energy is directly proportional to temperature, because temperature is responsible for the translatory motion, heat energy, and kinetic energy भी वही देता है, oscillation भी वही करवाता है, rotation भी वही करवाता है. तो these are the this is the way it works. Now if you think in terms of chemical reactions, then you think in terms of the bond energy, electron energy, etc. Now notice that if you have products and reactants getting created in a reaction, so on the left hand side you have reactants and on the other side you have products. Okay, so you have the products and the left hand side is a reactant. Now what happens? Delta U happens, change in internal energy is happening because of all these 1, 2, 3, 4, 5 reasons. And so you write it as जो भी final product बना minus UP, the internal energy of the product minus internal energy of the reactants. This is what gets seen in chemical reactions. But how do you do this? Okay, now if you have a system and you have a reaction taking place, NaOH plus, very strong reaction, plus the, right? What is happening here? Heat will get generated. Say the heat is allowed to leave the system. Now, simply speaking, if heat is allowed, you're losing energy. So the molecules or of NaCl and water that get created, sorry, this is HCl. Okay, and water got created and NaCl got created here. Inside, the product भी अंदर ही बन रहे हैं यहाँ पे. But heat is allowed to escape. So water or NaCl का level of energy will go down. So therefore, they will have less internal energy. So the product side goes down. Product side is less than the reactant side. So we will say there is a loss of internal energy, and internal energy changes negative, which means I have lost it. It was higher earlier, and because I allowed the heat to escape the system, the product side has become. So this is one way you can change. Okay, the other is you start doing work on the system. अब आपने सारा उसको वो कर दिया, आइसोलेट कर दिया सिस्टम को और आपने उसको इंसुलेट कर दिया और आप उसको ऊपर से दबा रहे हो वैसे. So now you're adding work to it, the heat is getting added, and when the heat is getting added, the heat has to appear somewhere. Generally, it appears, so work is done, work gets added as a heat. Heat appears in the form of increased temperature. अंडे वो उबालते हैं तो हीट ही देते हैं और अंडे का टेम्परेचर बढ़ता ही है ना. तो वर्क डन करने से वर्क इज अ वे टू ऐड हीट. किसी के अंदर हीट ऐड करनी है, डू वर्क ऑन इट. Heat will go inside it. Now, when the heat gets inside it, temperature goes up. Temperature goes up, matlab the translatory, oscillatory, rotational energy, the energy of the electron moving inside, all of that goes up. So we will say the kinetic, so the internal energy of the system has gone up. So another way to increase the internal energy of the system is to do work on the system.
ठीक है.
Now you're increasing it. If you allow the heat to escape, you're able to decrease it. If you do work on it and insulate it, you're not allowing any heat to escape, but you're adding heat to it. The temperature goes up. So this is very close to what I told you. It finally will boil down to this particular temperature. Okay. इसी पे it boils down to this कि heat add होने से temperature बढ़ा तो internal energy बढ़ गई. Now another way to increase internal energy is this. I have a reaction taking place and I add more quantity of the reactants. Okay. So you add more reactants to the system. आपका पास सिस्टम है, आपने उसके अंदर और केमिकल डाल दिया, रिएक्शन होना चाहिए आपका. व्हाट विल हैपन if there are more molecules, the internal energy will go up. चेंज की बात नहीं कर रहा, मैं सिर्फ बोल रहा हूँ कि मेरे पास एक सिस्टम है, उसमें इतनी इंटरनल एनर्जी है, मैं अब दूसरे सिस्टम में उसकी डबल क्वांटिटी ले लेता हूँ, तो सिस्टम रिएक्ट होके बढ़ेगी घटेगी, वो तो बात अलग है कि क्या हम कर रहे हैं, लेकिन क्वांटिटी से ही तो फर्क पड़ गया इंटरनल एनर्जी का. आइडेंटिकल NaOH और HCl लिया, दो दो लीटर या 4-4 लीटर लिया, किसके पास ज्यादा U है? जिसके पास 4-4 लीटर है. Right? Very important to understand internal energy for physics and chemistry. If you're understanding this, we are doing half your thermodynamics physics chapter. Khatam. Definition at least you know. थोड़ा थोड़ा फर्क आने लग जाएगा बाद में, बट ब्रॉडली यही कॉन्सेप्ट है, आइडेंटिकल है, कोई फर्क नहीं है. सो इंटरनल एनर्जी हैज टू बी अंडरस्टूड वेल, इंक्लूडिंग व्हाट आर द वेरियस वेज. ऑब्वियसली फिजिक्स के अंदर भी जनरली वी विल नॉट सी situations where we can जहाँ पे गैस ऐड हो जाती है, गैस बढ़ने से इंटरनल एनर्जी बढ़ गई क्योंकि नंबर ऑफ मोल्स बढ़ गए. सो टेम्परेचर ऑफ वन मॉलिक्यूल है तो टेम्परेचर ऑफ डबल द मॉलिक्यूल्स विल गो अप. सॉरी, द एनर्जी ऑफ द डबल द मॉलिक्यूल्स विल बिकम डबल. सो वो सब होगा, लेकिन कम सिचुएशंस होती हैं. केमिस्ट्री में ज्यादा अपॉर्चुनिटी हमें रिएक्टर प्रोडक्ट साइड, रिएक्टेंट साइड को बढ़ाने की, इंटरनल एनर्जी को चेंज करने की. सो हाउ डू यू कंट्रोल इंटरनल एनर्जी इज ऑल्सो इंपॉर्टेंट. Very important. Go slow on this. Please don't try to rush to say कि सीधा जी law कराओ, numerical कराओ. नहीं कर पाएंगे. फिर we will have to understand. I've given you a glimpse of how internal energy sign works and how is it associated with heat passing out, work being done on the system, and change in quantity of the material. Okay. Then we will after this what we will study is work done for each of the types of processes we did. आइसोथर्मल, आइसोकोरिक, आइसोबारिक एंड एडियाबैटिक. हमें याद नहीं करना, वो फिजिक्स का पार्ट होता है, बट हमें उसकी समझ आनी चाहिए कि हो क्या रहा है. दैट्स ऑल, नॉट मोर देन दैट. एंड देन वंस वी अंडरस्टैंड, नॉट एट द लेवल ऑफ फिजिक्स बट जनरली, जैसे हमने वहाँ PdV का फॉर्मूला लिखा था, 4 ग्राफ बनाए थे, उसके बियॉन्ड करने की जरूरत नहीं है. तो वी हैव व्हाट इज अ वर्क, व्हाट इज अ बैलेंस वी हैव टू स्टडी नाउ. वी हैव टू फर्दर ड्वेल डीप इनसाइड यू. इंटरनल एनर्जी में थोड़ा सा जाना है, वर्क डन स्टडी करना है 4 प्रोसेसेस के लिए. किसी भी थर्मोडायनेमिक प्रोसेस 4 टाइप के हैं, उनका अलग अलग वर्क डन क्या है. वंस वी अंडरस्टैंड दिस एंड दिस, वी विल एंटर इनटू द फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स, व्हिच इज वेरी सिंपल. इक्विलिब्रियम से डील करता है, देन सेकंड लॉ, then done. And then we will start doing all the relationships and different types of energies that we see in thermodynamics. We will go into definition of each one of them and what are the laws that govern those energies and what are the laws that link those energies to each other. So it's a very straightforward, thoda sa lengthy hai because of definition and thoda se too many terms are there. Entropy, enthalpy in this condition, enthalpy in that, entropy in that. That has to be memorized and understood also. कोई मुश्किल नहीं है.
ठीक.
ठीक है जी. See you tomorrow then. Please go back and revise if you can. Otherwise you will start getting what should I say, darkness, black हो जाओगे, बिल्कुल blackout हो जाएगा कि हो क्या रहा समझ नहीं आ रहा. And it's elementary, no complication is there.
Okay.
All right then. See you then. Take care. Bye. See you tomorrow.